and all. Is the screen visible to you?
Yes, sir.
Hmm. Do you have any doubt?
No, sir.
Okay. So today I'm going to teach you about the wave particles. First of all, I'm just teaching the basic of structure of atom. We didn't have started. We didn't start yet the structure of atom, but the basics of the structure of atom. So first of all, after this, I'm going to ask you a question from the previous class. That is, select isoelectronic set. Select isoelectronic set. More than one option can be correct. Na plus, comma, H3O positive, comma, NH4 positive. B, CO3 minus 2, NO3 minus, H2CO3. C, P minus 3, HCl. C2, H5 minus, and then there is pH. Again, D is F minus, Na, Na plus. More than one option can be correct. On Thursday, there will be test for half an hour. Every week, we will have a test of half an hour. Okay. It can be subjective, objective, and there will be only 4 to 5 questions. Please do this question.
Yes, sir. Just 1 minute. So there is one or more than one?
More than one can be correct.
Okay, sir.
Done.
Sir, A and B.
Only A and D. Let me check how many electrons does it have. 10,
Sir, 10,
10, and then 10. When we
32,
6 plus 32, and here
32,
32, and here
32.
A and B 10, 10, 10. P minus 3, 18 electrons, 18 electrons, 18 electrons, and 18 electrons. ABC, isoelectronic, that means number of electrons same. Let me check the D part. 10, 10, 10. That means A, B, C, D all are correct. Yes or no?
Yes, sir.
Okay. Now let's start a new topic that will be useful ahead. That is electromagnetic waves. Electromagnetic waves, we also call it EM waves, or we can call it radiant energy. Radiant energy. In this chapter, we will study that the electrons has dual nature, particle nature as well as wave nature. So we are going to study about this wave nature. The wave nature, that means there will be a wave like structure. This is a wave like this. Now this point is called crest. This point is also called crest, the above one, and the down one is trough. And then this is also trough. Now there are some terms which we need to discuss. Is first of all wavelength. We will discuss about wavelength, that is denoted by lambda. Second is basically wave number. Wave number, there is a space between wave and number. Wave number, that is denoted by neo bar. Then the third point, which is basically frequency, which is denoted by neo. Fourth one is time period, that is capital T. And the fifth one is velocity, which we can denote it by C. And the sixth one is amplitude, which we can denote it with small a or capital A. So one by one, we are going to define it, and after completing this topic, we will have some questions. So see, what is wavelength? We can define it by the distance between two consecutive crests, or the distance between two consecutive troughs is called lambda, that is wavelength, lambda. The distance between two consecutive crests, the distance between two consecutive trough is called lambda. Then we will talk about wave number and then frequency. See, this frequency is very important and time period. Wave completed in 1 second. Wave completed in 1 second, that is called frequency. And what is time period? Time taken to complete one wave. Time taken to complete one wave. Are you getting my point?
Yes, sir.
Just suppose if you are going in a circular path, then time taken to complete that circular path, that means circumference of the circular path is called time period. And what is frequency? How many basically how much distance you have covered, or how what is the circumference you have covered in 1 second, that is called frequency. And velocity, you know, the speed, you can call it. And amplitude, the maximum displacement from mean position. Maximum displacement from mean position is called amplitude. Are you getting my point?
Yes.
So just write it and then I will explain one by one again. Let me know whenever you are done with this.
Done. Sir.
Okay. Very good. Now there is wavelength, that is lambda. So I'm going to define it. Please write with me. Distance between two nearest crest or trough. Either crest or trough is called wavelength, and its SI unit is meter. Its SI unit is meter. This is our wavelength. Also remember some conversion which is very important for this chapter. 1 angstrom is equal to 10 raised to the power minus 10 meter. 1 picometer is also equal to 10 raised to the power minus 12 meter. 1 nanometer is equal to 10 raised to the power minus 9 meter. In this chapter, it will be very useful. 1 centimeter is equal to 10 raised to the power minus 2 meter. 1 micrometer is equal to 10 raised to the power minus 6 meter. 1 Fermi meter is equal to 10 raised to the power minus 15 meter. These are very important. Now the next term is basically wave number. Wave number, no bar. So this is basically, it is reciprocal of wavelength. It is reciprocal of wavelength. Reciprocal of wavelength, and we can have a formula here. Nu bar is reciprocal of wavelength. That means this. Nu bar is equal to 1 by lambda. So SI unit we can write is 1 by meter, or we can write per meter, or we can write meter inverse. So this is the second term, wave number. Please write it. per meter per centimeter, it can be anything.
Done, sir.
Very good. Now the next term is frequency, that we denote it with the nu. Nu. So I'm just going to define it. It is defined as, it is defined as the number of waves which passes or pass through, the number of waves which pass through a point in 1 second. In 1 second. So this is the definition. Basically, we can say from a given point, the number of wave passes in 1 second is called frequency, and its unit is hertz, that we denote it by Hz, and now it is per second, per second, per second, and its old unit is cycle per second, cycle per second. Cycle per second. So this is about frequency, and the fourth is time period. Total time taken to complete one wave, or we can define it like time taken by a wave to pass one point. Time taken by a wave to time period, and we can have a relation. Nu is equal to 1 by t. That means frequency is equal to 1 upon time period. Frequency is equal to 1 upon time period. And you know the unit second. Please write.
Done, sir.
Now, then velocity comes. Fifth is basically velocity. Velocity here we denoted by c. Always remember that this electromagnetic waves speed is equal to the speed of light. And do you know speed of light in air?
Sir, and vacuum.
Yeah, it's almost equals to air and vacuum are almost equal. That
3
is
into 10 to the
3
power
into
8
10 raised to the power 8
meters per second.
So, very good. So the speed of electromagnetic waves are equal to the speed of light in air or vacuum, that is 3 into 10 raised to the power 8 meter per second. Now this c will be equal to lambda, wavelength, distance. You already know that this speed is equal to distance upon time. So we take distance as wavelength upon time. So this is the formula we will get. C is equal to lambda upon T, lambda upon T. And you also know that since 1 by T equals to nu, so we can modify this formula and we can write C is equal to lambda into nu, or nu is equal to C by lambda. Just rotate it. Or if you want to write lambda's formula, so it will be this. Yes or no?
Yes, sir.
This is the velocity part. Please write it. Always remember that frequency is inversely proportional to lambda. So any wavelength which has more frequency, that means lesser lambda wavelength.
Done, sir.
Done. Now the last term is amplitude. It is defined as height of crest or depth of trough. That is called amplitude, and the unit is, since it is height, that means distance, meter or centimeter it can be, according to our requirement.
Done, sir.
Very good. Now I'm going to give some questions on this topic. Calculate nu bar per centimeter and nu of yellow radius having a wavelength of 5800 times.
So we have to calculate nu bar in centimeter per centimeter and nu in
Meter,
meters.
just uh, calculate it in meters.
Okay, sir.
You can do it easily.
Yes, sir. So we need to calculate in decimal, like complete solve, or I can leave in fraction.
A fraction is enough. Don't do
Okay, sir.
go for
Okay, sir.
because it will take time. Can you do this or I should explain?
Sir, I got the first part. I didn't get the second part.
See, it's very easy. New bar we need to calculate and wavelength is given. So you did this, you did like this, and just first of all convert this lambda into meter. That will be 5800 into 10 raised to the power minus 10. We will multiply and it will be converted into meter. Again, I can write 58 into 10 raised to the power minus 8 meter. Yes or no?
Yes, sir.
Now just put the value 1 upon 58 into 10 raised to the power minus 8. That will be approximately equal to 1 by 58 into 10 raised to the power 8 per meter. This is your answer for the first?
So we have to calculate in per centimeter. Will be 10 to the
No,
power 10.
meter. I told you to
No, so
calculate it
in
into meter.
new bar you wrote centimeter, right?
Oh, calculate in centimeter. Oh, sorry. I didn't see that. So if you're going to convert it into centimeter, it will be just divided. Do a thing that, wait a minute. Directly convert this into centimeter. You'll get your answer. So in centimeter, it will be 5800 into 10 raised to the power minus 8 centimeter. And then just put the value 5800 into 10 raised to the power minus 8 per centimeter. Okay. Then you will see 10 raised to the power 8 upon 5800 per centimeter. And then two zeros will be cancelled. 1 by 58 into 10 raised to the power 6 per centimeter. Yes or no?
Yes, sir.
This will be your answer. Now, again, this is the first part and second part. Second part is nu. We need to calculate nu. And you know that nu is equal to C by lambda. Since it is radiation, electromagnetic waves, so its speed of light will be 3 into 10 raised to the power 8. And what is the value of lambda? 5800 angstrom. So angstrom 10 raised to the power minus 10, you can calculate it into meter. Meter, and it will be cancelled and the answer will be in second. Yes or no?
Yes, sir.
So we can write directly like 3 upon 5800 into 10 raised to the power. This will be positive 18. And then we can also write 3 upon 58 into 10 raised to the power 16%. Yes or no?
Yes, sir.
Very good. If you are going to convert this into centimeter, it will be also easy. You see lambda nu is can be equal to, as we know that 1 by lambda is equal to nu bar. So can I write c into nu bar? And what is the value of this? Is in meter per second. This is in meter per second. So in centimeter per second, its value will be 3 into 10 raised to the power minus 10 centimeter per second, and into nu bar has a value that we got 1 by 58 into 10 raised to the power 6. We can get answer from here too. Are you getting my point?
Yes, sir.
Okay, please write it. Let me know when you are done with this.
Done, sir.
Very good, Arnav. Now the next question is basically the wavelength range of the visible spectrum extends from violet, that is 400 nanometer, to red, 750 nanometer. Express the wavelength, or with these wavelengths, in frequencies. Please do this. Let me know if you're done. Have any answers?
Yes, sir. For violet, it's 3 by 4 into 10 to the power 6 hertz.
Wait a minute. What you just said for violet?
3 by 4 into 10 to the power 6 hertz.
Okay.
And for red, it's 1 by 25 into 10 to the power 7 hertz.
Hmm. Can you tell me the answer of violet?
3 by 4 into 10 to the power 6 hertz.
Only 6 hours.
Yes,
This
sir.
is wrong. See, uh, Arnav, the first I am going to solve violet, which has a lambda that is equal to lambda v is equal to 400 nanometer. And we need to calculate frequency. So frequency is a formula that is c by lambda. And if you are going to take the value of c as 3 into 10 raised to the power 8 meter per second, so you have to convert this 400 nanometer into meter. And for converting this into meter, we have to multiply it by 9. So it will be converted into meter. Now see, 400 into 10 raised to the power minus 9. Meter will be cancelled by meter. And you can see, if you are going to solve it, 3 by 4 into 10 raised to the power minus 7 left. And here it is 8. Now 3 by 4 into 10 raised to the power 15 hertz it will be, or per second. Yes or no?
Yes, sir.
So I think you have just put the value of 400 nanometer, right?
Yes, sir.
Okay. So please recorrect it. Is there any unit test in your school?
So right now it's summer holidays.
Oh, nice.
Yes, sir. For red, it will be 1 by 25 into 10 to the power 16 hertz.
Okay. So in case of red, you can see new red will be equal to 3 into 10 raised to the power 8 upon, it will be 75 into 10 raised to the power minus 8, right? So it will be 1 by 25 into 10 raised to the power 16 hertz. Yes or no?
Yes.
Now see another question I'm going to give you. What will be the wave number of yellow radius? I will give you some, uh, I will give you option to having wavelength 240 nanometer. Now the option is 1.724 into 10 raised to the power 4 per centimeter. Option B is 4.16 into 10 raised to the power 6 per meter. Option C is 4 into 10 raised to the power 14 hertz. Option D is 219.3 into 10 raised to the power 3 per centimeter. Please do this carefully. Are you done with this?
Just a minute. Sir, it's B,
B, yes.
4.16 into 10 to the power 6 per meter.
Okay, very good. So in the next class, we are going to start the main topics of the structure of atom. Okay, like
Okay, sir.
Rutherford's experiment and all.